The idea of a system of any type of equation, or inequalities, is to find points that are true for all of the equations in the system. When I was dealing with linear equations, I was looking for a set of points that made all of the statements true. That was true for all of the equations in the system. And with linear equations, it was either a point or a line with infinite solutions. Here, inequalities give regions of the graph that are true for it, not simply a line. So, what I'm going to be looking for is when I graph both of these lines, I'm going to be looking for regions of the graph that are shaded that both of these share mutually. And that will be the solutions for the system of linear inequalities. So I'm going to graph both of these, and I'm going to first rearrange them into y is equal to mx plus b. Start with this one. And the second one is simple enough. So I'm going to put both of these lines on the graph. I'll begin with this first one. I'll graph that one in red. The y-intercept is 2, and when y is equal to 0, minus 2, 3, 6, divided by minus 2 is positive 3. Now, if this were a line, I would be done. However, this is not a line. This is an inequality. And the first thing to notice is that this is not a greater than or equal to sign. So this needs to be a dashed line, because the line itself is not included. This is now a dashed line. And now the next thing to do is to figure out which region to shade of this graph, the bottom part or the top part. In this case, it's easy to tell just by looking at it, but if it wasn't, I would test a point, and the easiest point for me to test is 0, 0. If 0, 0 is a true statement, then this bottom part of the region of the graph would be shaded. If it was an untrue statement, that would mean the other side would be true. So I will test 0, 0. Two times 0 plus 3 times 0 is greater than 6. 0 is greater than 6, which is false. That means the region with 0, 0 is not true, and this top region is. So that is what the graph of 2x plus 3y is greater than 6 looks like. But this is a system of linear equations. So I need to graph the other one. I don't know why, but y is greater than 0. Y is greater than x. So y is greater than x. That's an easy one. The y-intercept is 0, and the x-intercept is 0, so that won't help me. But y is equal to mx plus b. The slope is 1. So if I start at 0 and go up 1, 1, and my line will look like this. And this is a solid line because it's greater than or equal to, or y is less than, or x is greater than or equal to, y is less than or equal to, however I'm looking at it at the time I'm watching this. Now I need to test a point to see if this part of the graph is shaded or this part of the graph is shaded. And to do that, I normally would pick 0, 0, but in this case 0, 0 is on my line. So I will pick another point. I will pick 0, minus 1, which is right here. So if 0 minus 1 is true, this bottom part is shaded. If it is false, this top part is shaded. Fortunately, y is greater than or equal to x is easy to test. I tested 0 and minus 1 for y. 0 is greater than minus 1, so this bottom part of the graph is shaded. And now there is an area here that is shared mutually by both of these equations. And this is the part here. This region here is the solution to the system of linear equations. It's difficult to express in any other way besides graphically. That's what it looks like.